everyone. Myself Sravanthi, working as the assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is bootstrapping. So here we are going to discuss what is bootstrapping, what is self-hosting compiler, what is cross compiler with an example. So bootstrapping is nothing but it is mainly used in the design of a compiler. So here a compiler can be categorized into three languages like source language, target language and the implementation language. The source language is nothing but the source program which is written in a high level language that is understandable by the human. The target language is nothing but it is the output that is nothing but it is understandable by the machine and it will be in the object code. The implementation language is nothing but here the compiler is written it can be written in any programming language like C, C++, Java or Pascal, Python, any language it can be written. The compiler is nothing but it's like a translator which translates the source program into a target language with the help of some programming languages like C, C++, Python, Java, any programming languages it can take. So here the bootstrapping is nothing but it is mainly used to produce the self-hosting compiler. So the name itself tells us that self-hosting is nothing but it compiles itself. Nothing but compiler is a type of a compiler that can compile its own source code. So the self-hosting compiler is nothing but it compiles its own source code. So that is nothing but the bootstrapping produces the self-hosting compiler. So here the T diagram. So how we represent these bootstrapping? We represent these bootstrapping. It is in the shape of a T diagram. So we will call these bootstrapping it a T diagram. So the source language is here and the target language and this is my implementation language. So it looks like a T shape. So we can represent these T diagram as source language and this is my compiler and the target language and it is implemented in implementation language. So this is a representation of a T diagram and it looks like a T shape. Let us go for one example. So how this bootstrapping is implemented. So let us take that A is my source language and B is my target language and I have written these in some let me take it as written in a Python language. Python. It is the implementation language is Python. A is my source code and B is my target language and Python is the implementation language. This Python is not understandable by the CPU. As Python is in a high level language, the CPU understands only the machine code. So we are going to convert this Python into a machine language. So to do this, the next step what we are going to do is this Python will be taken as a source language. This Python will be taken as a source language and it is the target language is nothing but the machine code. This Python is converted into some C++ language. It is converted into C++ language and this C++ is also a high level language. This cannot be understood by the CPU. CPU understands only the machine code. So we are going to convert this C++ into a machine language. This C++ is taken as a source code and the target code is machine code and it understands the implementation language is C. The implementation language is C. Here the C is also a high level language. It cannot be understandable by the CPU. CPU understands only the machine language. So we are going to convert this C into a assembly machine code. So the C is then in the next step, the C will be the implementation language will be our source code and the machine language and we are going to convert it into the assembly language. The implementation language is assembly language. So these assembly language cannot be understood by the CPU. The CPU understands only the machine code. So we are going to convert these assembly language into a machine code. So to do that, this assembly language is taken as a source code and we are having the machine code as the target code and the implementation language we are going to have is the machine language. So this is nothing but this whole process to generate is nothing but we'll be calling it as a bootstrapping. This is nothing but we'll be calling it as a bootstrapping. So here A is my source language and B is my target language and Python is nothing but my implementation language. So the implementation language can be any programming language. So I'm taking here Python is my programming language. But Python is an high level language and it is not understandable by the CPU. The CPU understands only the machine code. So we are going to convert this Python into a machine language. So to do that, in the next step, what we are going to do is this implementation language is taken as a source program and we are going to have the machine language as the target program and I'm going to take implementation language as C++. So the C++ is also not understandable by the compiler or CPU. So we are going to convert this C++ into a machine language. So to do that, in the next step, we are going to take C++ as a source program, and machine language is nothing but my target program, and we are going to convert it using the C language. So the C is the implementation language, but still C is not understandable by the CPU. The CPU understands only the machine code. So we are going to convert the C into a machine language. So to do that, we are going to take C is the implementation language as the input, and we are going to generate the target program as machine language, and it is the implementation language is taken as assembly language, but still the assembly language is not understandable by the CPU. So here we are going to convert these assembly language into a machine language. To do this process or this procedure, we are going to call it as a bootstrapping. So bootstrapping is used to design the compiler, and here it is used mainly, it is used to produce the self-hosting compiler. So nothing but it compiles its own source code. So it looks like a T diagram, looks like a T shape, and the representation of that is nothing but source code, target code, and implementation language. C is nothing but the compiler. So this is nothing but the representation of this bootstrapping. The next is cross compilation. So cross compilation is nothing but where a compiler runs on one platform. It runs on one platform but generates machine code for different platform. Here we are going to generate the machine code for the different platform. So when we are going to do this, we need to keep concentration is nothing but the implementation language and the source language of implementation should be same. Here the target language and the implementation should be same. So let us take here L is my source language and N is my target language. S is my implementation language. S is my implementation language. So let me take here one more machine, nothing but L is my source language. So in the second machine also, the source and target languages should be same. L is my machine source language, N is my target language, and the machine language, nothing but the implementation language, I am taking it in different one. So that is nothing but M is my machine language. Let us assume these are some variables I am taking. So here the cross compilation, the implementation language will be here. The implementation language of the first machine, yes, should be my source language, and the target language should be my the second machine's implementation language. So that is nothing but M, and it is producing the machine code for a different platform. Here in the cross compilation, the first machine so implementation language and the target levels implementation language, these both should be same. If both are same, then we will call it as a cross compilation. So in this cross compilation, these things should be same, and it is generating the machine code for the different platform. We are going to cross compile these one. This is one machine and this is one machine, and we are going to take these implementation language and this implementation language, and we are going to generate the cross compilation. So it is nothing but where a compiler runs on one platform and produces or generates machine code for the different platform. So here we have discussed what is bootstrapping. Bootstrapping, it is mainly used to design the compiler, and what is self-hosting and what is cross compilation. So cross compilation is nothing but we are going to compile one compiler runs on one platform but generates the machine code for the different platform. And we also seen one example how to construct the bootstrapping and what is the shape of this bootstrapping and how to represent this bootstrapping. Thank you.